Good evening, everybody. Welcome to our offices in Charlotte Street. It's nice to see you all here this evening. My name is Cormac Deavy. I lead our property science, industry and technology business in the UK IMEA, and I'm going to be the moderator of the discussion and the conversation this evening. But before I get into introducing the talk and the speakers, a little bit of housekeeping. So first thing is, we're not expecting any fire alarms this evening. So if a fire alarm goes off, it means you do have to exit the building. And the fire exit is just there behind me, out onto Howland Street. And the muster point is in Fitzroy Square. So fire alarm, you gotta leave out that way and go to Fitzroy Square. You come in from Charlotte Street in through our main entrance, but you might have noticed that there was some works going on in the foyer. That work will be continuing later on. So when we finish this evening, we'll be exiting, you go up these stairs and across and out onto Whitfield Street because the work will be carrying on out front. So that's a bit of housekeeping. There will be guides and people from Arup staff around the floors, and it is signposted to get you out of the building at the end of the evening. So the plan for this evening is we have our two speakers, which I'll introduce in a moment. They're going to speak for about 15 or 20 minutes each, and I'm going to try and hold them to time, which is easier said than done. Then there's going to be a conversation with questions from yourselves, and then there's time at the end of that to reconvene around drinks and nibbles to continue your conversations about what you heard in the evening or anything else that you want to talk about. So our talk this evening is about the Sydney Opera House and why it was so far ahead of its time in terms of the impact it had on the place, on Sydney and on the people, but also the innovation that happened that we're still learning from and using today. So we've got two fantastic speakers to talk us through that. First, taking the stage is Tristram Carfrae, who's an Arup Fellow. Arup is a structural engineer, and he has an unswerving commitment to designing better buildings that consume less resources, materials, energy, time, and money. He's recognized in the industry, and I think it was just last week, Tristram was awarded the Sir Franco Whittle Medal by the Royal Academy of Engineering, which is the highest accolade for engineering in this country. So many congratulations, Tristram. Thank you. I suppose one of the many reasons that he was awarded that is that he has contributed to some of the most significant projects that Arup has done across the world. And his most recent work is helping to complete the design of Gaudi's amazing church, the Sagrada Familia in Barcelona. And I know that's a passion project for Tristram. And then we have Peter Murray. Peter here in the front row, OBE. Peter is he trained at the Architectural Association, but turned to writing and journalism instead of practice. He was editor of Building Design and of the Reba Journal. He's the founder of London Festival of Architecture and co-founder of New London Architecture. He was invited to write the Saga of the Sydney Opera House, and I did read it a few weeks ago, Peter. Interesting book, interesting read. By Sir Jack Zantz, who is our former chairman of Arup and who led the engineering design of the Opera House for OBE, Arup and Partners. Jack had become frustrated following comments by the architect Jorn Jutsen, which did not properly reflect Arup's role. So so Jack, our past chairman, made available the files and letters that were kept under lock and key in our offices for 30 years, made them available to Peter so he could shed some new light on the story of the Opera House. So without further ado, Tristram, over to you. There are two speakers. Over to you, Tristram.
Thank you. Thank you, Cormac. Well, I'm looking forward indeed to hearing what Peter has to say afterwards. We haven't conferred or compared notes, so it'd be interesting to see to what extent we agree with each other or otherwise. But over to Jack.
The first image I had of Sydney Opera House was a rather curious one. I was in South Africa working with an architect, and he showed me the now well-known profile of the competition entry for Sydney Opera House. And it was so unreal. One looked at it and I said, good heavens, this is fantastic. But of course it can't be built, it won't be built.
Fortunately, Ove didn't share that opinion, and when he saw the competition winning entry, he immediately wrote to Jorn Jutsen, slightly against, I think, the received ethics of consulting engineering, to put himself forward as the engineer, saying that that Jorn needed Ove, and particularly his partner Ronald Jenkins, who we'll talk about in a moment, to help realise this amazing project. And here you see Ove with Jorn in Jorn's hometown of Hallenbach in 1959. So this is the brief, sort of the dot points of what happened when. 57, he wins the competition. The start on site in 1959 was perhaps precipitously early, but driven by the then minister, Joe Cahill, who sponsored the project, who was determined that once you start something, it's hard to stop it. And he was worried about whether he would still be the minister after the upcoming election, so he got going on site perhaps a bit early, which had some significance. Then we had stage 2, the sails and the tar lids. Then we had Utsson's resignation, talk a bit more about that later. And then the stage 3 construction with all the interiors and the glass walls. So stage 1 and stage 2 were actually led by the engineer, and only stage 3 was led by the architect, which is slightly unusual. So the project was split, if you like, into 2 parts. Here we see stage 1, the monumental pediment, if you like, on which the Opera House is mounted. It's a fantastic, I think, bit of design and architecture in its own right. The whole of the Opera House is sculpted out of this pediment and sits, nestled in this massive flight of steps. The construction of this was by Lend-Lease, then called Civil and Civic. As far as I know, the construction went reasonably well. There's nothing I've heard in particular about stage 1, except that it took the attention of the design team away from the designing stage 2. They were so concentrated on all the issues that come up, through a live construction site, that perhaps the progress on stage 2, the sales, was not as rapid as it might have been. Stage 2 was initially designed by Ronald Jenkins, you see here, with another future chairman, Paul Arm, another Dane, working with him, on the basis that the design should have been a lightweight concrete shell, such as those that Ronald had designed at Bryn Mawr Rubber Factory, for example. It was quite a common, if you like, architectural engineering approach at the time to make things out of thin concrete shells. But load testing of a polycarbonate model down at Southampton University showed that actually this particular design, or the shape of the design at that time, was not very amenable to shell theory. And if we look more closely at this wind tunnel model, you can see that the sails at the top are relatively flat, and then they increase in curvature as they come down to the base. All the force is concentrating into that area where it's also being bent round a corner, which basically is not membrane action or shell action. So essentially it just doesn't work. This form does not work as a concrete shell. And we can see that on this historical, this was published in 1973 on completion of the project, showing the sort of evolution of the design. This is the first of 2 pages, but I'm only going to show you the first page. Top left, originally that form as a single shell, rapidly developed into a ribbed shell to give it bending stiffness and strength to deal with that corner. Even that was insufficient, so it became a double shell, bottom left. And that continued until 1961, at which point even that avenue was seen to be a dead end, and Ronald Jenkins left the project, and that was when Jack Zuntz was brought back from South Africa to lead the team. His preferred solution was actually a steel space frame. You see in the top right, first 2 images clad with concrete, and as some of members of Foster and Partners here might recognise, that was an inappropriate architectural resolution of the desired outcome. And so the bottom right, the idea of precast concrete ribs instead was adopted. There was some controversy over the geometry of the Sydney Opera House sails as to who did what when. And this accurately, I think, says that on the right-hand side, circular arcs were being used, by us at least, to describe the shell, but the ridge line was a parabola, so it wasn't yet what it became. When it became a set of precast concrete ribs, it was a confused structure in that it wanted to work in bending as a set of ribs and in shell action still as membrane forces developed between the ribs. And this was a difficult thing to calculate by hand. A shell can be calculated mathematically, but this combined bending shell was not amenable to straightforward hand calcs. So we resorted to the computer for the first time. So this Pegasus computer here on display at the V&A Museum was used again both at Southampton University but also at the headquarters of Ferranti, the manufacturers of the Pegasus. The computer programs are written by the engineers, largely by Peter Rice, who was a young graduate at the time and amenable to mathematics and digital calculations. The capacity of the computer couldn't do the whole calculation in one go, so there was one program did the sort of bending calculations, and one program did the shell calculations, and then they were merged, if you like, to give the final outcome. And then in middle of 1961, we get the eureka moment when Jorn decided that the whole geometry should be cut from a single sphere. And that actually resolved everything else, because we already had precast concrete ribs. We now had a geometry that was amenable to construction and to repetition and to understanding, which I'll talk a little bit about more. But I'll hand over now to Jorn and Jack Zuntz talking to Ingham Ashworth, who was a professor of architecture at Sydney University. He was one of the judges on the jury of the original competition. He was a technical advisor to the Opera House during the whole design and construction process, and was one of the first trustees of the Sydney Opera House after completion.
So each element of the sphere has been separated as a unit away from the whole so that it can be pre-made, prefabricated, and then assembled together. Now, each of these elements is identical for the whole entire room.
Coming back to the orange again.
Coming back to the orange, yes. You cut up each slice of orange.
You can actually make a whole sphere of this just a part of it.
Yeah.
This is only part of the sphere, yes. And the difference being, if you look at a member here, or an element there, it's exactly the same element, except that the one is longer than the other. Now, here we can see now how one element will be taken away from the whole. Now, we're going to make these elements by precasting. They'll be concrete, they'll be hollow, and they'll be precast on the ground, probably on the site, in small pieces, yes. And these pieces, this is just to illustrate these are the pieces, they're somewhat out of scale. Each will weigh 10 tons. And at this stage, of course, we have to try and collaborate very closely with a contractor who will play a most important part in the design team.
At which point, Hornibrook entered as the contractor for stage 2 of the Opera House. And they were the most creative, inventive, and can-do contractor I think you could ever meet. And their first thing that they brought to the design team was this idea of an erection arch. So recognizing that every rib is the same, they recognized they could use a bit of temporary works with a telescopic bottom that could then be extended rib by rib so it always matched the leading edge of the construction as it was being built. There were 8 of these used, 4 to the south and 4 to the north, that followed or led the construction. And that was a phenomenal piece, I think, of sort of creative design from the contractor to help build the project. And to show how things were being done together, this sketch is actually by Arup about the construction process, from using the information that we gathered from Hornibrook and the approach. And the whole thing is set out there. You can see pieces are made actually off camera, if you like. They're brought around the little truck at the front there is bringing a piece. It's lifted up by the derrick crane. It's then going to be lifted by the big crawler-mounted, rail-mounted hammerhead. The largest cranes in the world were imported specially to do this job, and then lifted into place between the erection arch and the existing structure, the structure built today. And here you can see, in reality, that's exactly what happened. There are 3 of the big cranes, one to the south doing both halls, and then one for each hall to the north, who sort of built the building, then gradually retreated, out of the picture, if you like, and left behind the completed construction. And you can see in the right, that's the casting bed. So the actual making of the pieces was also done off-site, but on-site, if you will. It's not on the site of the building itself, but adjacent, made in those beds, stored all the way around the edge of the site, and then lifted into place. And this later shot, it's the same thing now looking from the south. So the casting beds, the bottom right, the storage yards, bottom left, all up the side of the building actually, and then lifted in either from the north or from the south and put into place. So these are the elements. Precast concrete, match cast. So they were cast typically in 4s, each one up against its neighbour, because the joint between them is going to be filled with only 3 millimetres of epoxy. So each one has to be exactly mated up to its neighbour to create that 3mm joint. And in fact, for the next batch of 4, number 4 was taken out of the first bed and was used as number 1 in the second bed to make sure the matching carried on all the way up the rib. Here we see one element, one rib piece being put into place. You see on the left the construction arch with its wonderful spherical bearing at the top being mounted off the top of the ridge beam. On the top of the piece, which is sort of behind you in this camera shot, are 2 steel strongbacks which support it initially, and they span between the existing construction, the rib before, and the erection arch which leads the way, and they hold the rib temporarily in place. And then the rib is post-tension. The epoxy is squished, if you like, and these steel strands, high-strength steel strands, are threaded through temporary collets and wings and stressed time and time again as you extend the arch. So that jack on the right with a double piston arrangement that allows the tendon to go through it and continue was invented specifically for this project. In fact, the whole idea, I think, of the flying wedges and collets that would grip the strand and then release the strand again when it was pulled from further up were also designed specifically for this project. There was one deficiency in the erection arch, which was it was much more flexible than the concrete ribs that had already been built. So every time you put on a new piece, it deformed a little bit. So it was quite hard to decide whether it was in the right place or not. So every night, or during the day, lots of theodolite readings were taken of the new piece being put in. And every night, a computer program was run at Sydney University, again written by Peter Rice, who you can see on the left here, to try and compute whether it was in the right place or not. And then the next morning, adjustments were made on the ends of those strongbacks to pull it into the right place before it was stressed back and the next piece was put into place. So that this was the second use, if you like, of digital computers. I think a very nice touch, if you ever go to Sydney, is to see, if you wander down the 2 main corridors either side of the auditoria, these pre-stressing pockets where all the pre-stressing strands emerge at the bottom of the ribs are still there to see. And Peter would always talk about the mark of the maker as being an important thing to leave behind when you finished a construction project. And this is where he got that idea from, if you like, initially. So this is my favourite current project. Hang on, it's not running. Here we go, yeah. So these are the panels we're now using to make the big towers at Sagrada Familia, and they are bits of stone masonry, in this case cut by computer rather than moulded, pre-stressed together with stainless steel rods and glued together with mortar and then erected as complete units. So here we are 60 years later, performing exactly the same process that was invented, on the Sydney Opera House. And for me, the sort of punchline of this construction, or this modern methods of construction, as we now call it, 60 years later, it's been christened modern methods of construction, is that the whole of the cost of the works at Sagrada is paid for by people who come to watch it being built. Okay. So we've also turned construction into a theatre, into something that people want to see and watch, and not something which is a deficit or a detriment on the community. And I hold that the building of the Opera House was actually its first public performance, because it was done in full sight of all the inhabitants of Sydney as they crossed the Harbour Bridge and went to and from work every day. The next stage was the tile lids. On the left there you see Jorn Utzon inspecting one of the prototypes of the tiles. I think those are not the final tiles. The border tiles I think are duller than the actual ones which are in the middle shot. On the right, you see one erected on site to make sure he was in the right light. Was it what people wanted? These were then attached, mass-produced. They were cast with the tiles placed face down in the mould, and then the concrete, which was only 45mm thick, cast behind it, so they were glued directly to the concrete by the concrete itself. Yeah. And then they were erected on the top of the shells using these amazing brackets. These are bronze brackets that are fully adjustable in every dimension, so that even though the precast concrete is accurately only to about 1 inch or 25mm, the tile lids are there to about 2 or 3mm, so that they're absolutely flush, the panel joints are absolutely even, and they also accommodate for the contraction and expansion due to thermal, due to the sunshine during the day and then going away at night, whereas the precast behind stays relatively stable. And it's all in those details, which are just exquisitely designed. They're better than any detail I think I have seen ever on any other project. And the result is this amazing building, you know, the building that everybody knows, that has become an icon and a representation not just of Sydney, but perhaps even of Australia. And I love the quote from Louis Kahn, American architect, who said that the sun didn't realise how beautiful its light was until it saw it reflected off the Sydney Opera House. Yeah. And that is what these people created 60 years ago. And today, this is the pinnacle of Sagrada Familia. There's a CGI's left and top, but bottom right is the full-scale prototype that's just arrived on site last week. And you can see it's just echoes of the same thing. And again, we are casting the concrete straight against the tiles. And again, the concrete is 50 millimeters thick. So it's a sort of weird sort of repetition of exactly the same thing. So going back a little bit, 1966, Jorn had a major disagreement with the New South Wales government and resigned from the project. He'd completed the design of the whole of stage 2, which was, as you can see, well under construction, but not yet complete. And at which point the government appointed a new team of architects.
The government appointed this trio, Hall, Todd and Littlemore, to take over. Peter Hall of the three, he was the designer. He was a very likable man, very nice man when we met him.
And they had this enormous challenge of completing the Opera House between the podium of stage 1 and the sails of stage 2. This contract, led by the architects, was far larger in scale and substance than either of the two preceding contracts. And the biggest task they had was trying to enclose the Opera House itself with these glass walls, because the geometry of the sails and the geometry of the podium, which if you remember was constructed before the geometry of the sails had been determined, were totally unrelated. And I had to also enclose it in a way that created enough space for the foyers to the north between the two. So it was an amazing task, and again, I think incredible collaboration between architect and engineer to resolve that geometry into something that could be built, could be made, could be understood. Again, computer programs were written from first hand to develop this idea of two cones and a cylinder which shared a common axis by which the mullions, therefore, could migrate from one cone to the next cone to the cylinder, all in a single plane. The walls were made with laminated glass. Laminated glass had never been used at anything like this scale before. The codes of the time, or the design principles, where you designed the two panes as independent things, taking half the load each. But primary research by Arup, by a guy named John Hooper, determined that that was correct for dead load, but a long-term load, where the polyvinyl butyl interlayer would creep, but it wasn't the correct approach for wind loads or short-term loads, where the glass could work as a composite. So we developed, or Arup developed, codes of practice for designing laminated glass for the Opera House, which are still the basis of the codes used today. So another first invention. And again, the details here to accommodate the difference in tolerance between the facade of 1 or 2 millimeters and the steelwork of probably 10 or 15 millimeters are exquisite. And these were actually developed in collaboration with Hawker de Havilland, makers of aeroplanes, in phosphor bronze. And they're just beautiful, just beautiful. So again, today, something like the Bombay Sapphire Distillery with Thomas Heatherwick is using exactly the same approach to glass design that was developed back then, 60 years ago. So in the interest of time, I'll bring this to a conclusion, which is, there it is, 1973, opened 51 years ago. For me, there are so many firsts here that it's difficult, to break them all out, but there are 9. Integrated design between architect, engineer and contractor, digital computers, modern methods of construction, early contractor involvement. That erection arch was brought to the table before the contract was actually signed for stage 2. Glued segmental pre-stressed precast concrete construction, now used commonly for major bridges all over the world, never been used before. Mass-produced precast tilings, laminated glass walls, new materials everywhere. Who knew you could build something with plastic in 1960, glue things together? And ultimately, for me, it's about longevity, that when you produce some work of this quality, it carries on and becomes, as I said, the representative icon of not just a city, but a a whole country. It also made Arup. We were good at what we did before that. We worked with some modernist architects in the UK and were producing good stuff. But this project took us onto the world stage. And more importantly, I think, it gave the people who worked on it the confidence and the courage to break with convention and to dare do things which had never been done before. And I know I would not be here speaking to you today if I hadn't learnt from those people. They made me, if you like, who I am today. So thank you.
Brilliant. Thanks, Tristram. Get your questions ready for him. He will be open to them later on. But now we have Peter, who's going to talk to us about how the transformative nature of the building for society and for Sydney. And so, Peter.
Yes, well, that was such an all-encompassing description. I need to find those bits which Tristram hasn't actually covered in the way that it goes through. And to a certain extent, my interest is also with the relationship of architect and engineer and what impact Sydney Opera House, and the impact was fairly great, had but in that relationship. So I'll also start with a picture of Jack Zuntz. And we were at the opening of the Great Court at British Museum in 2000. And he came up to me and he said, "I'm really angry." He said, "We've got to do something about this." There's a film which has just been shown called The Edge of the Possible about the Opera House. And so the Utzon team had said that Arup actually struggled to solve the problem of designing the shells. And that Utzon had, as Tristram says, solved this in a sort of Archimedean moment, because he actually was in his bath. And it's either a ball or an orange he had in his bath. You can see the sphere, the line around the sphere. But the way that the Utzon team described it was not the way that Jack saw the story. And that is very much to do with the way that the iterative nature of design and the way that things go. So Jack said, as Tristram said, that there had been files kept by Arup afterwards. They had not revealed them publicly because the ending of the relationship with Utzon was so difficult that the files were put in a cupboard and nobody looked at them for 30 years until I retrieved them from the back of Turlough O'Brien's desk, which they've been sitting there since 1973. So I'll just tell the story from, I'd say, the architectural point of view. And the engineering was great, but it didn't always quite match up to the thinking around what Utzon had in mind. And of course, we start with this sketch, which of course was called by the art critic of the time, Robert Hughes, as nothing more than a magnificent doodle, which is really what Jack mentioned, I think, on that bit of film. And of course, he had designed very little by then. I mean, his two major projects were really nice housing at Kingo and Fredensborg in Denmark, but they were small projects. So Sydney was something out of the ordinary. His entry also was number 218 out of 222. So he just scraped in the time. And that might have been a hint to people about his general view of timekeeping, which was a source of some frustration to the engineers. And the judges were, here is Saarinen is the closest to it, and you also had Leslie Martin. Leslie Martin had, a few years before, of course, designed the Royal Festival Hall, and Saarinen at the time was working on the TWA terminal at Kennedy Airport. So you can see, looking at this, you can see why he then came into the judging room. He was held up, he arrived a bit late, he went through all the sort of rubbish on the floor that the other judges had thrown out, and there was Utzon's scheme, and he said, "This is the one." And he managed to convince them that this would be the right one for them to choose. And so they did. And this was sort of what it looked like, and it was very much in the design frame of very popular shell structures at the time. A lot of people doing them. So you have Felix Candela, there's the Kresge Auditorium by Saarinen, and down at the bottom the poultry market, which is soon to be opened up again, which was done by Jenkins, Ronald Jenkins, and his middle initial was S, so he was known as RSJ, which is rather good for an engineer, isn't it? And then the picture to the right is rather interesting, and that's in Tallinn, in Estonia, and that actually everyone thought they were being very progressive in the 50s and 60s doing shell structures, but actually that Tallinn building was built and designed by Christiani and Nielsen in 1917 and is about the same proportions and depth of concrete as the poultry market, which was done some 50 years later. But Ronald Jenkins was the Arup expert at the time on shell structures, and so he set to work on it. Now, big discussion among everyone going in for the competition is, do you put the two, there were two halls required, do you put them side by side or end to end? And it is a very narrow site, and this is Pierre Boissevein's solution. They got third prize, London practice, and a firm called Boissevain and Osmond. And his view, when he saw that he'd lost, said that Utsen's design was brilliant but fatally flawed. And there were a number of flaws in it, even from the early days, in terms of the capacity of the building. And one of the key issues was that he decided on the side-by-side version here. It was very tight on the site itself, but also he had this rather wonderful bank of stairs which provided access to the seats in a sort of Roman amphitheatre sort of way, which was a brilliant design. We could also got over the problems of having additional fire escape. So it was very efficient, but it meant that you have to approach the seating by going to either side of the stage area itself, and that actually constrained the size of the stage areas of both the main hall, the lower one, and the smaller hall above. And when it was used for opera later, the chorus of Aida would sort of have to queue round the block before they could come in and walk down to the stage. So what the brief that Utsen was given was for the lower is a multi-purpose larger hall for concerts, large-scale opera, ballet and dance, choral, pageants and mass meetings. But again, there is a problem there, not Utsen's fault in terms of the brief. Nobody had really done these sort of mixed halls before. And of course, you have an issue that, opera likes a proscenium, concerts don't. I don't know what mass meetings require, but certainly something probably different. Opera requires shorter reverberation times, concerts require longer. So lots of issues of actually squeezing everything in. And the smaller hall was supposed to be for dramatic presentations, intimate opera, chamber music, recitals, and lectures. So when Utsen actually won the job, it's interesting to see why it had that shape that it did. And this is really quite important in terms of the outcome and O's view of the final design, was that you have the higher shell in the, might say, the middle of the composition, because that's where the fly tower is, and that means that you needed a bigger shell. And if you can remember what it looks like when it's finished internally, it all ended up slightly differently. But as you saw earlier, your picture is a bit sharper than mine, Tristram. But anyway, this is the podium which Utsen had designed. He had been inspired by Mayen, architecture, and he saw this as a plateau, and which you would gradually walk up, and then you walk up the stairs into the theatre itself. And one of the sort of interesting things about this is that it does entail one of the, might say, great pieces of collaboration between OBE and Utzon. And the thing is, you see, they were both Danes, as you probably know. And one of the things that Utzon had written as soon as Utzon had won the competition, OBE wrote to him, which was seen in those days as touting. Now you would call it marketing, but then it was touting. And Jack was always a bit shocked when he told that story. But Utzon had already been told that he needed somebody like Arup or Christiani Nielsen, one of the two, because amazingly, when he put in his doodle for the competition, he had not had any engineering advice at all. So he started without an engineer, which is the sort of thing that engineers obviously point out that it doesn't work. So as we heard, the three stages were really important. So you had the podium, then the shells, and then the interior. Now, of course, one of the big issues that it had all along was that the costs kept going up. It's not unusual for buildings of this scale, but this was at a pretty massive scale of increase, really, partly because the original shell structure was seen to be almost just 3 to 6 inches of concrete, and the local quantities of airs costed about 3.5 million Australian dollars. But it had soon grown, as soon as they got on site, to 10 million. And the sort of problems that they had to face, no fault of the architects for sure, and not of the engineers either, because Arup weren't involved in the brief, and the geology of Bennelong Point, where it was, it hadn't really been surveyed properly, and everyone thought it was there's a Hawkesbury sandstone, which covers most of the water side at Sydney, and in fact the site itself was loose alluvial deposits permeated with seawater. So some 700 concrete shafts needed to be put in before any work could start. So that started ramping up the costs. But also, as Tristram mentioned, Joe Carhill, the Prime Minister, he saw this building as his legacy. He knew he was very ill. He wanted them to get on with it. And so the podium went ahead before anyone knew how much the shells were going to weigh, or even where exactly they might land. So that created one issue, and some of the columns later had to be changed. And in terms of doing things in full sight of the people of Sydney, that the tops of some of the columns had to be blown off with dynamite, and they managed to do that when there were hooting going on in the harbour and other noise which would mask it, until a lump of concrete landed on commuters' cars they were driving past on the Carhill Expressway, so their cover was blown, as it were. But I think really one of the very fascinating things about this project is the relationship between OBE and Utzon. And it was almost at that stage, it became perhaps almost a father-son relationship. And OBE believed, at least, I think he believed all the way through, that in Utzon he had found the perfect architect with whom he could collaborate in his own personal quest for total architecture, which is something, it's an approach that dissolves the disconnect between engineers and architects. It's something he'd been seeking his whole career, and is the basis of the collaborate attitude of Arup's, which everyone reads the key speech when they come here. Still, do they? They still do. Good. So there's a few more drawings, the ones that Tristram showed, but basically there are a lot of iterations at the start. So the key thing about these is that RSJ, and in fact the whole team in those days, to them, they believed the architect was the leader of the building team. And so he had done this design. He knew they knew they had to calculate ways of making it stand up. But what Utzon wanted, they thought they had to stick to. So for 3 years, Jenkins tried to make Utzon's drawings work, both the external shape, but also the internal finishes that he was looking for. And so these are some of the iterations. And the complaint that Jack had about Utzon believing that he'd solved the sphere issue was that for a lot of the iterations, the engineers had been discussing either spherical or toroidal solutions would actually provide that repetition. So they hadn't come up with a solution, but they'd laid the groundwork for Utzon to then have his Archimedean moment. And so this is the famous model which shows how those sections are all cut out. So then things started to move on quite quickly, or rather more slowly, even though the computers were being used. When alarm bells started ringing when Utzon would like to change things, but the computer then, down in Southampton, it took about 2 weeks for it to accommodate any changes. And so people started to realize after a time that actually you'd never finish the building anywhere near the time that the Queen wanted it to be finished so she could open it. And so alarm bells were beginning to ring that how do we actually pinpoint what the solution should be. So Jenkins got very depressed after about 3 years of not being able to come up with a solution, got rather depressed. He wanted to give up, and Ove was also getting slightly frustrated about it. And so he then replaced Jenkins with Jack. And at that time, the double-skin version was sort of top of the heap, really, in thinking about it. And then there was a meeting in the offices here. Utzon was working most of the time in Hellebeck, just north of Copenhagen, but they came over here in 1961, and Ove had been thinking about the idea of the rib idea, that is the one which was finally decided upon, and that when Utzon saw that, he said, "I don't care what it costs, what scandal it causes, but that's what I want." And even Ove was slightly surprised that he was so enthusiastic because, I mean, it changed the shape for a start, but also it decreased the internal volume, which had already been a problem right from the start of the project. But, however, said Jack, Utzon exuded that air of assurance and confidence which brooked no argument. We thought that both visual and functional matters were in a safe pair of hands. And that, I think, explains the relationship between architects and engineers in those days, a relationship which, you know, some of you might think has changed slightly over the intervening years. So then there came a stage in 1963 where it was realised they needed to move to Sydney, because one of the issues at the time was that a flight to Sydney cost about the same as a 3-bedroom house in those days. That there were telephone calls, you had to book them up. You've also got time difference, and you couldn't hear a lot of things going on. So it became very frustrating with things on site. So Mick Lewis, the chap on the left, who was a sort of no-nonsense engineer, had been working with Jack for a long time, had been in South Africa, arrived, and this is Jack on the right, and of course Ove in the centre. And the job of the engineers was to get the shells up, and then Utzon came, and his job was to complete the interiors. But one of the problems with Utzon was that he left about the same time as the Arup team left to go to Sydney, but he then went on a 3-month tour of China and Mexico because he wanted to sort of have a look at Mayan and also Chinese Song dynasty detailing. But of course, in those days, no mobile phones, no email. He was just hors de combat for 3 months at a critical point when a whole series of decisions had to be made, and that did actually annoy. Particularly, as I say, Mick Lewis, very down-to-earth chap, that annoyed him as more than anybody else. But also at the same time, the London partners were getting a bit fed up because it seemed that Utzon was expecting Arup to do all the drawings. That actually they thought, Arup thought that that was the architect's job. But then it sort of came to a bit of a point. The wonderful tiles on the roof, of which there were about 1 million, were suddenly given to Arup to do all the drawings for that, whereas again that was thought to be the job of the architect. So there were a whole series of issues which then started to accumulate as, I might say, relationships got a little bit tense. And the main job of Utzon at that stage was to find a way of designing the internal shells which would provide the acoustic protection from the harbour outside, but also the necessary reflection of the acoustics internally. And it was very difficult to come to a conclusion about, one, how they'd be constructed. Utzon had an idea for huge plywood sections which would be fed in. Hornibrooks couldn't see how even you could get those across the water, let alone heave them up into position. And also they would have impacted on the structure of the shells themselves. So Mick Lewis kept asking Utzon for drawings, and drawings weren't forthcoming. And the Liberal government had just won an election, and Liberals, Conservatives over there, won the election on the basis they were going to bring the costs of the Opera House under control. And there was a chap called Davis Hughes, who was the minister whose job it was, and he brought in a thing, what they called checkbook control. At the time, Utzon had been paid, whenever he sent an invoice to the Sydney Opera House committee, they would pay it. I mean, it was they just were quite easygoing with the checks at that stage. So the minister thought checkbook control was what was the answer, and so he would then only be paid on the basis of delivering work, of which the key bit of work at that stage was drawings for the internal shell. That meant that Utzon became rather hard up, and he got slightly frustrated. And on February the 6th, 1966, he went to see Davis Hughes about his fees. Hughes said he would look into it. Utzon said, "I'm going to resign." Hughes said, "That's no way to speak to a minister of the Crown." And Utzon walked out, and later that afternoon sent a letter to the minister saying, "You have forced me to leave the job," and that he had dismissed all his staff. Now, I think it's not unreasonable of a minister to expect that Utzon had resigned. But it was later claimed that he didn't mean to resign because they were so sure that the minister said, "Oh no, don't go, we'll have you back." And Bill Wheatland, who was with him in the meeting, and it was number 2 in the office, says, Utzon said as they were walking out, "Don't worry, I bet they'll come running after me." But they didn't, and there were huge protests at the time, local architects and students, and the response to a lot of that is quite important as one goes forward, because there were some who suggest that Arup should have resigned at the same time, but their contract was with the government, and Jack Zuntz said there was no way we could walk away from a contract where the client had treated us so well. And so Utzon left Sydney, never to return, never actually to see the building at all, and they needed to find a way of continuing the design. And there was a lot of discussion between OBE and Utzon as he was packing up to go home. And but actually, although they had this great relationship, the two of them didn't actually meet again until 1977, when Utzon won the Royal Gold Medal at the RABA, and they shook hands and exchanged pleasantries, and that was all. But at that time, and this is a picture taken by Peter Hall, the architect you heard earlier who took over. They dominated the place. There were some people who thought it ought to just be left as a massive sculpture, and it would have looked very dramatic. But instead, Hall, Todd and Littlemore. Hall was a very bright young architect and was selected by the government architect as probably the best person to do the job, and Hall and Littlemore were the executive architects. And together they delivered, as you heard, the huge and very important glass wall. And also they had to design the interiors, which Hall then went round the world looking at other concert halls, talking to acousticians, looking at buildings like this one, the Kunio Maikawa Saitama Concert Hall, which had a very similar sort of feel to some of the models that Utzon had done for his selection of interiors. But Hall just had to really imagine what Utzon wanted, because when and he believed when he started work that he was just going to take over from almost a fully completed design. He was just to carry out Utzon's designs, and there would be plenty of drawings to show what Utzon wanted to do. But when the architects went to pick up the drawings, the cupboard was bare, and the Utzon architects had actually taken away some about 5,000 drawings, and they didn't re-emerge until 1973 after the building was open. So really, Hall was starting again, and the few drawings they could find were deemed as preliminary, and but it didn't affect the work that was going on site at the time, because, as I said earlier, they hardly did any of the drawings at all. Arup had done all the drawings, so that work continued on fairly well. But one of the key issues was that there were no drawings to show how many seats the theatres could actually contain. So Peter Hall went round the world. He looked at all these places, and he came back with the view that actually the minor hall, the smaller hall, should become the opera theatre, and that the major hall should be concert only. And that simplified the acoustics, it simplified the layout, but also he found a way of solving the problems of the number of seats, because although Utzon's rough drawings had shown about 2,500 seats, and the Sydney Symphony Orchestra, who were going to occupy the space, they needed more like 2,800, 2,900 to make it viable. The fire brigade had thought that Utzon was putting his seats too close together, and that they would have never have permitted them to build it like that. So getting the seats in was a real issue, and one that then Hall solved by taking out, because it wasn't going to be used for opera anymore, taking out the fly tower from the larger hall and extending the seating into the area which was the fly tower, i.e. the tall shell. And the tall shell then became basically a shell with nothing in it, which was then OBE was rather shocked at that, and he thought that was not a good architectural solution. But that was then what happened, and this is a view of the interior as designed by Peter Hall. It was hugely criticised at the time by mainly local architects, and there was a continuing battle between him and the supporters of Utzon. But when they came to renovate more recently the hall, Utzon was involved in that, and he didn't suggest any changes to this interior at all, and presuming that he was actually fairly happy with it. And here you can see that the way that he managed to get more seats was by having seats around the back of the orchestra in that sort of vineyard organization. And when it was first used, the acoustics seemed to work pretty well. It got reasonably good reviews, and the Queen then came to open it. That was in October the 20th, 1973. It was just 16 years after Utzon won the competition. So then things get very interesting in that there was an exhibition which took place in Sydney in 1994, which was called Unseen Utzon, and somebody had turned up this model which shows this is what Utzon was thinking about how to fit in the hall under the shells with these large plywood swooning roof ceiling, and as you can see, the fly tower is still there, and he is unable to actually get the number of seats in he needed. But the supporters of Utzon thought that they hadn't counted the number of seats properly. Utzon had solved all the problems. So the story behind this exhibition was Utzon had solved all the problems. It was quite wrong to change him. And that actually then had a rather good impact, that the Sydney Opera House started thinking, well, we ought to see how we should develop the Opera House in the future, and that that should be in line with Utzon's basic thinking. And so they started to do that, and there was Richard Johnson of JWP Architects. He was the consultant architect. He got in touch with Utzon. They developed a document of design principles, which Utzon was very satisfied with, of changes that would happen over the lifetime of the theatre, and became particularly relevant when this latest improvements and changes which took place leading up to the 50th anniversary, which we're celebrating now. And so Johnson said that Utzon, he went to visit him in, I don't know whether he was, it was in Denmark, but at that time Utzon was spending a lot of time in Cairnlys in Mallorca, which was two beautiful houses he'd built overlooking the sea. And Johnson said he read it slowly, looked up and said, wouldn't it have been marvellous if the Acropolis had had such a document, which he took as being accepting the fact that Utzon liked the proposals, that Johnson then tried to convince Utzon to come and visit the building. They even tried to hire Kerry Packer's jet to fly him there, but he didn't want to go, and he told the journalist Anne Maria Nicholson, I have the Opera House in my head like a composer has his symphony. He can at any time go into the symphony and hear it. So this led to then, starting in 2012, a whole decade of renewal with ARM architecture, Aston Raggett McDoodle running this, and they, as I said before, they kept the basic form of Hall's interior the same. They changed some of the reflective panels, but the basic arrangement is pretty much as it was. And this is another view of that. There were lifts included into the building, which there weren't before, because equity was one of the key issues they want to address as they were making these changes. But up until then, people had to climb some 50 risers in 2 flights of stairs to actually get up to even the most convenient seats. But anyway, there was, as I say, a lot of tension between the local architectural profession, Utzon, why he was sacked, should he have resigned, all those sorts of debates. But now peace reigns, and I'm sure a lot of it is to do with Tristram and his very diplomacy in Sydney, because in the Royal Australian Institute of Architects, they posthumously awarded Peter Hall their 25-year award in recognition of his role in the Opera House, which unfortunately was a bit too late, because Peter Hall, the stress of doing the work had actually had a major impact on his mental health, and he died age 64 with absolutely no money and as an alcoholic. So that was very sad, and at that stage people really didn't know very much about the role that he had played, and it was only about 5 or 6 years ago that an Australian academic went through all his diaries, which had been found by his son in a garage, and realised that actually Hall had done a much better job than a lot of people had thought at the time. So anyway, the original cost after the Shell quote, which I mentioned, was only covered a part of the building, but the original proper estimate was 9,624 Australian dollars. The final cost was $102 million. There are some people who might suggest that this is just the epitome of the architect as someone who keeps changing everything and pays little attention to cost. But actually, a lot of the problems were not Utzon's fault. A lot of them, the client body, the organisation, and I say so, the brief had its omissions. But even though it went way over, it was worth it. As part of the 40th anniversary, Deloitte produced a report, and they estimated then the value of the Opera House was 4.6 billion. So that's not a bad return. But what are the other things, other impacts that the Opera House has had? One of them, it got, in the UK, it got architectural competitions a bad name. The RIBA really stopped proposing architectural competitions, not just because of the Opera House, there was also the Architects Benevolent Society had a competition for their Wallingford home for ageing architects, and that was decided by Nick Lacey, and there was a big falling out between the client and Nick Lacey, and that was all blamed on the competition system. So that has really set back the sort of competition for a long time, and we are beginning to see some improvement. There are people who now deliver very effective competitions to work, but for a long period of time, competitions were quite difficult. And when they came back, actually Arup was generally on everyone's list as consultants, because they'd obviously done such a good job at Sydney. Project management, and Jack always felt that this was a turning point in the relationship between the architect and the people who manage projects, because as I say, they treated Utzon, leader of the building team, but found they were doing a lot of the work themselves. They actually had to manage the project, and he saw this as one of the issues that actually increased the rise of the project manager. And you know, the architect's place was unassailable, and that then changed. And I think also, though, that at the same time, that relationship between OBE and Utzon really was, while it was working, was reflected the culture whereby the sort of integration of all technologies involved in design, construction, it was a start of a more fruitful relationship between architects and engineers, and you see that in that grew following Sydney. It also, of course, heralded the rise of the icon architecture and also Starchitects, and that's something we might talk about a little bit later. And one might think, looking at the way that OBE actually got the job, maybe it heralded the beginning of professional marketing. But also, that little box you saw, that computer, that started something really, and that was the first major project where computers were properly accepted as delivering the sorts of information that engineers needed, although it was rather slow. And the Elliott 4120, which Arup were using, had 32 kilobytes of memory. But it was quite impressive in writing its data on magnetic tape at 33,000 characters per second, which seems quite impressive until you hear that a modern workstation laptop computer in Arup today has up to 4 million kilobytes of memory. It can write to a solid-state disk at around 3.1 billion characters per second. And so Arup's most powerful computer is at least 10 million times more powerful than the Elliott 4120. So you can see, one, they can design buildings much quicker, but if they'd had even just a laptop in those days, Utzon might have actually completed the job himself. But just one modern laptop contains more computing power than the entire planet had in 1968. But by contrast to that, the flights, as I said, between Sydney were really expensive. Telephone conversations were really hard. So actually going through the files, what one found is a host of wonderfully written, handwritten letters. And all the engineers working on they were very poetic, actually. You know, it's not maybe some normal image of engineers, but they wrote brilliant letters, very evocative. And I think somehow writing allows people to communicate in a better way than we do by email. Emails maybe just get too brusque, and but these letters well worth a read. Generally, the majority of them very friendly. There were times when they got a bit tense, and also even reading those, they are very expressive and understanding exactly what was happening in a way that I think reading emails wouldn't. And I would say, finally, why weren't the files that were given to me 20 years ago released earlier? And I think it says something that, because in spite of, there was a level of rancor that happened towards the end of the project, but there was absolutely no desire of Arup to damage Utzon's reputation or even his future prospects. So the files were hidden away for a number of years, and I found that to be something to be hugely magnanimous, admirable, and rather moving. Thank you very much.
Wow, where to start? I'm going to give Peter a chance to catch his breath after that. I did read your book, Peter, The Saga of the Sydney Opera House. It's a good read, and if you want to know even more from what Peter said, it's all in here, so it's worth a read. But while Peter catches his breath, Tristram, I've got a question for you, just to kick things off, and we'll go to the floor then. Peter in his book talks about a magnificent feat of engineering and the story of construction being one of triumph. Now, I think that must be music to your ears, absolutely. But he talks about this building, how it launched the third phase of modernist architecture, you know, the right of expression above pure function, rather than the kind of traditional, or at the time, the form follows function concept. But in an age where we might say form needs to follow environment, what do you think that means for our industry of engineers, architects, contractors in the design and construction of buildings today?
Well, you know, it is interesting to me that I don't know how Utzon came up with the idea of the shells, which accommodate the volume of the building, but they don't echo the volume of the building, if you see what I mean. So they're an independent form from the building it contains. And I think, you know, environmental concerns today would say that was a profligate use of material, perhaps, you know, to do that. However, on the other side, I would say that the approach of modern methods of construction, of prefabrication and on-site assembly and minimising waste is very much on point for what we try and do today. So it's a mixed story, I think I would say, a mixed scorecard.
So we have a roving mic, so if you do want to ask a question, put your hand up and we'll make it the mic on its way to you. So on the front row, we have Mike Taylor. Mike from...
Hi there, thanks. I'm just looking at that image behind you, and I've not been there, I've not seen the building. I'm kind of intrigued by those folded plates at the bottom that you don't really get to see with the beauty of the pure spherical. When did they come in? They look almost like a necessary addition to a pure idea.
Almost true. They came late. The early drawing showed a curved element in there, but that didn't meet the sort of repetitive requirement. So the side shells they are referred to as, and they were came after the spherical geometry. I don't know much about the detail of who decided on their geometry. No. In fact, there's a piece, well, some of them are, it's difficult to see. There's a piece in here which is quite a radically twisted surface that accommodates from that piece of spherical to that piece of spherical. So they're a mixture.
Kind of hierarchy of purity.
Yes, yes.
Peter, maybe you've caught your breath now. I have one for you. Yeah. Then we can go back to the audience here. But you talked a little bit about the impact of the Opera House on Sydney and how it's repaid its investment many times over. I think 4.6 billion evaluation by Deloitte 10 years ago. And the brand is priceless. In the current context, how important is it that as an AEC or construction and design and construction industry, in collaboration with cities and local government, that we continue to create places of this stature? And what do you think we should learn from? There's great innovation that happened on the Opera House, but there was some challenges as well. What are the main learnings you think we should be taking from that to take into creating places of the future of impact?
Well, I think as far as the iconic architecture is concerned, I think the age of icons like that is over, because actually, if you've got a lot of icons, they start losing their impact. And I would say that well, even Sydney was about branding Sydney. Basically, Melbourne had the Commonwealth Games a few years before, and Sydney always felt very much second city. And they saw the Sydney Opera House a way of, getting their own back at Melbourne, really. So there was quite a sort of local competition at that stage. But then, as you say, it became a global phenomenon, really. And Bilbao and other places have succeeded in making themselves known to a wider world through architecture. I think it's quite interesting if you look now what is happening. I would say that city-wise and iconic-wise, in terms of city branding, one of the strongest images that we've seen since COVID, particularly, is the pedestrianisation of the Champs-Élysées by Anne Hidalgo in Paris, and I think it's quite interesting and somewhat amusing that actually the first real move that Sadiq Khan makes into the built environment, because he's always rather, he hasn't really got involved in building very much, apart from paying for a bit of housing. But he's not somebody who sees the physical change in the city as being his job. And he came up with pedestrianising Oxford Street as a sort of icon to compete with Paris. And so I would say that the things that attract people to cities now are much more around, people-centered city. I think sort of something that Jan Gehl really kicked off. The success of Copenhagen is very much to do with the changes that he brought about, and I feel that that's very much what is the sort of key brand for successful cities in this part of the 21st century.
Great, thanks, Peter.
Can I add to that, Cormac? Sorry.
Yeah.
At a different level, it's not really so much as icons, but for me, I think if you look at the investment in carbon of building things, then you also have to get a return on that investment. And the return comes best from longevity. And longevity in this context, two things. One is things that are well loved, get looked after, remade, reused, adapted and into the future. And the second part is that things that are continuously renewed throughout their life as well. So we are now, I think, on about our 30th project with the Sydney Opera House in terms of, redoing the concert hall, changing the logistics, adding a car park. It's a continuous process of keeping buildings current as well.
Actually, perhaps I could add to that. I mean, two things. One, that I think they had to keep Arup on because you know where all the tension rods are in the. But one of the things that the last couple of days I've spent at the Council for Tall Buildings and Urban Habitat meeting in London this week, and there. It used to be the case that they were just about bigness and, competition with the tallest tower, all that sort of stuff. Now the conversation is much more about contribution that tall buildings make to density and growth in cities. So it's a very, very different approach than just building something huge like the Burj Khalifa again.
Absolutely. Tristram, I've one for you. And any hands, put them up, we'll get to you. One for you. You talked about all the innovations that were there, this use of phosphor bronze in as a structural material, laminated glass, the thin epoxies. So a huge amount of innovation, I think, that could only have been achieved through that collaboration between contractor, engineer, and architect. Maybe a bit of a provocative question, but do you think we back ourselves enough as an industry today to really innovate for the better of what we do?
Well, the short answer is no, I don't. I think there was a sort of post-war confidence and a belief that the future was better, and therefore a bring it on, let's see what we can do, how far can we push things, because of this belief that you're creating a better future. And I think today we worry about whether the future is better or not than our present condition, and we're hesitant, therefore, I think, to do things that are radical or different or break convention. But that's a personal view.
Yeah, Peter, I think in your book, when I was reading it, you talked about how the project stretched those involved to the limit professionally, personally, and you also say psychologically. And it got me thinking about the environment we work in today as an industry. Are we really set up? Do we have the right environment to triumph together? And maybe, Tristram, what you say about we're not innovating enough. Do you think there's something around the culture and the environment we create that stops us from doing it?
Well, I mean, I guess we are rather more conscious of some of those issues today. Certainly, as I say, Peter Hall had a really hard time, and I think that somebody today would have actually noticed that he was suffering from real mental anguish. I think of being rejected by his peers, all his work being criticised, and as it turns out, when Utzon saw it, I think rather unjustly. And actually, I think the interiors weren't half bad, but his diaries have now been published, and it's a pretty tragic story. And I would like to think that now somebody wouldn't get that far without somebody noticing and taking care.
Thank you, Peter. Okay, well, do we have one question? Yes. Okay, go for it.
Hi there. Hi. Thank you both. Really fascinating. I'm really lucky to have been to both the Opera House and to Canley. And when I was at Canley, I sort of sat there in that beautiful courtyard looking over the sea. And I was thinking about the Opera House. And I wonder, or I was wondering, and I'm interested in what you think, if you've both been there, about whether the Opera House or that building most captures what Utzon was about as a person and as an architect, and because I saw some similarities in a very pure expression of structure, space, light, architecture in both of those buildings, although almost at opposite ends of the spectrum. So maybe just a reflection on where which of those would be Utzon's spiritual home?
Peter, do you want to take that one?
Well, I mean, to a certain extent, after Sydney, I would have thought almost Bagsved Church was more his spiritual home. So smaller project, but a lot of the issues around light and change of space within a very simple building. But also, I mean, his housing was great quality, small project, and suddenly there's this huge project that, as I said, he hadn't had an engineer tell him that what he was suggesting wouldn't work, and so small architectural practice. There were half a dozen of them, way in the sort of north of Copenhagen, in the woods, literally in the woods, and I think that they actually found it very difficult to just cope with the scale of the project. A lot of very good people turned up there because it's such an exciting project. Lots of people want to work there. Moneo drew actually quite a lot of the circular drawings very beautifully. So there were good people on the team, but they really just found it very hard to deal with the complexity of it. I think it was first job of that scale to do it, and which is why Utzon says, or said before he died, he said, without Arup, this would never have been built. And to a certain extent, the interest I talked about the Wallingford competition, which went horribly wrong. And there, the solution was to have what they, in those days, called an uncle, i.e. you get the bigger practice to come and help you deliver it. But I don't think Nick Lacey got on with his uncle very well. But to a certain extent, Arup were the uncle. They made it happen, and without them, it wouldn't have done. And I would say the contrast between Carnlease and the Opera House is so huge. But it tells you a lot about his thinking as an architect, because he went up on the cliffs there and he sat there for months and weeks on end, looking at the different views and finding out how he would place the stonework to maximize that place. And I would say at the end of that project, he probably felt happier with that than he did the Opera House.
Right. Thanks, Peter. I think we'll draw this part of the evening to a close. We can retire down here, continue the conversations with Peter, Tristram, and yourselves over some wine, drinks, and nibbles. But before we do that, can we put our hands together and show our appreciation?
Well, I'm sitting on my hands here, but I feel I need to tell just one little anecdote at the end, which sort of connects. So John Nutt took over from Mick Lewis, both on the Opera House and also forming Arup in Australia, and was led our practice there for 25 years. Every year, John Nutt, Corbett Gore, who led the Hornibrook team, Jack Zuntz, and a guy called Malcolm Nicklin, who represented Oricon, who then were MacDonald, Wagner and Priddle, who represented us for the stage one of the Opera House before we moved the team to Sydney. They played a foursome of golf, and the rules were that the losers would buy the four people a Sydney Opera House lottery ticket, which was the way the government actually funded the project. This blowout in funds were funded through a lottery. And the extraordinary thing is that one year they won. Okay. And John used the proceeds of his winnings to buy a boat, which he called Come By Chance, which is to the lottery, but also to a famous poem in Australia. So I was sailing with John on his boat, Come By Chance, and he introduced me to the sailor of another boat, which was a guy called Bill Burrows. And Bill was one of the Hall Todd and Littlemore architects, and they'd become friends on stage 3 of the Opera House. And Bill introduced me to his daughter, who I'm now married to and have lived happily ever after. So I have a huge debt to this project.
I'm glad he cut in so he could share that story. Thanks, Tristram. Wonderful. So, as I was saying before, let's put our hands together and show appreciation for two fantastic speakers. make your way down here and continue your conversations over some refreshments and nibbles. Thank you very much.